Good day and welcome to my campus guide channel. And today we're going to talk about introduction to basic engineering mechanics. One may ask, what is mechanics? When we say mechanics, it's a branch of physical sciences that deals with the conditions of rest or the motions of body under the action of forces. So this branch of science deals with the condition of a body at rest or in motion under the effect of an acting force. Mechanics is a broad subject under engineering. For this reason, it is subdivided into three groups. These are the rigid body mechanics, the mechanics of deformable bodies, and fluid mechanics. But in this scope, we are going to dive more into the rigid body mechanics. One may ask, what is a rigid body? We can say a body is rigid when the particles inside that body they are interconnected together in such a way that the mutual distance within them remain invariable under all circumstances. So when a particular body contains particles which are arranged in such a way that the distance between them are invariable under all circumstances, then we can say this body is a rigid body. The rigid body itself is one of the idealizations of mechanisms. But in rigid body mechanics, it's also subdivided into two. We have the static and we have the dynamic. When we talk about static rigid body mechanics, it deals with bodies at rest. So when we want to consider a body at rest, then we can talk about the static rigid body mechanics. The other subdivision is the dynamics, which deals with bodies in motion. And under the dynamics, it also have two subdivisions. We have the kinematics and the kinetics. One may ask, what is kinematics? When we say kinematics, then we are talking about the geometry of motion without making reference to the forces acting on it. So when a body is moving by a force and we consider that moving body without making reference to the force acting on it, then we are talking about kinematics. That's that branch of dynamics. But when we talk about kinetics, then we are talking about the study of the relationship between the forces acting on the body and the resulting motion. So these are the subdivisions of rigid body mechanics. So the other subdivisions of mechanics are mechanics of deformable bodies and fluid mechanics. Under the mechanics of deformable bodies, we have the strength of materials, we have the theory of elasticity. Yes, we can't talk about deformable bodies without making reference to elasticity and plasticity. When we talk about the theory of elasticity, this is telling us about how a material can be stretched or expanded. So whenever a material exceeds its elastic limit, it loses the ability to be called an elastic material. So it tends to be a plastic. So under there, you hear about the theory of plasticity. And the last branch is the fluid mechanics, which also has two subdivisions, which are the mechanics of compressible fluids and mechanics of incompressible fluids. Now we are talking about motion of bodies. We can't do this without making reference to the almighty Newton. So this will take us to the Newton's laws of motions. Newton's proposed three laws to define motions. Let's look at these laws. The first law was talking about a particle in its state of rest or constant motion will only change when it's being acted upon by an external force. So you say a particle or body will remain in its state of rest or constant motion unless it is acted upon by an external force. And the second law was talking about the rate of change in momentum is directly proportional to the external force, and it takes place in the same direction of the force. So the second law of Newton was talking about the rate of change in momentum, which is directly proportional to the applied external force, and this must take place in the same direction as the force. And the third law of Newton was about to every action there is an equal and opposite reaction to it. But did you know that this Newton's law of motion, his laws of motion had limitations? When it comes to atomic sizes interacting within atomic distances, the Newton's law was not applicable. For these reasons, it gave this law some limitations. So I have two limitations for the Newton's law. When we talk about dealing with bodies of atomic size interacting with atomic distances, that means we are entering the realms of quantum physics. And when it comes there, the Newton's law of motion is not applicable. And also, when we deal with bodies moving at a very high speed, approaching that of light, the Newton's law is not applicable. The only law that can be used over there is the theory of relativity, which was proposed by Einstein. So now, after talking about this Newton's law, there is the need for us to look at forces. One may ask, what is force? We can define force as any action of one body on another which changes or tends to change the state of rest or the motion of the body acted upon. So if the action of a body will affect the other, it will affect its state of rest or its motion, then we can call it a force. One or more forces can act on a body. So when two or more forces act on a body, we call these forces system of forces, or we can call it force systems. So when we say force systems, this is when several forces act on a body or a group of bodies. When it comes to classifying this system of forces, you classify them according to how the lines of action of the constituent force are arranged on the body. So we can say a system of forces are collinear, coplanar, or parallel due to how their lines of action of the constituent force are arranged. So we can classify them as collinear. That is when they act along the same line. We can say some system of forces are parallel. We can also say some system of forces are coplanar. That means they lie in the same plane. Or we can say they are concurrent, which is their lines of action intersect at a common point. System of forces or force systems can act on a body and the body will still be in equilibrium. When this happens, we say this system of forces are balanced or they are equilibrium system of forces. So now let's look at the characteristics of forces. The external effect of a force on a rigid body depend on the following three properties. We have 1, the magnitude of the force, 2, the direction of the force, and 3, the line of action of the force. So we can call these three properties as the characteristics of forces. So the effect of force on a rigid body would depend on these three, which is the magnitude of the force, the direction of the force, and the line of action of that force. So if two forces are applied separately to a rigid body, they will produce the same external effect on the body if and only if they have the same characteristics. That means they have the same magnitude, these forces have the same direction, or they have the same line of action of the force. This will take us to the principle of transmissibility. One may ask, what is this principle about? The principle of transmissibility states that the external effect of force on a body will remain unchanged if the force is replaced by another force of the same magnitude and direction, but acting at different points on the line of action of the original force. So the principle of transmissibility is talking about how the external effect of the body will remain unchanged if that force is being replaced by another force with the same characteristics, that is the same magnitude and the same direction, but is acting at a different point on the line of action of that original force. So join me on the next episode on how to resolve this system of forces to get a resultant. I believe this video was helpful and is an introduction to basic engineering mechanics. Don't forget to subscribe to my channel. Thank you.